Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Walker Grant Middle School. And in this video, we're still working on that SOL review guide. However, now we're still on that 8.6, but we're working now with just those rectangular prisms. So that's that 8.6b. So make sure you can use that formula sheet for yourself and that Desmos calculator. So we're mainly going to be looking at what happens when you change a attribute, meaning, a height, the width, or the length of that rectangular prism, what happens to the surface area, and what happens to the volume. So make sure that you're reading those questions carefully and be able to compare those values for yourself. So for number 1, it says this. It says a rectangular prism is 16 inches long, 4 inches wide, and 12 inches high. A new prism is created by changing only one of the dimensions of the original prism. The volume of the new prism is 1/4 of the volume of the original. Choose all of the following could represent the dimension of the new prism. So it's saying, all right, so let me do it like this. It's saying, okay, I have the original is 16 inches long, the original is 4 inches wide, and 12 inches high. And since it's saying, okay, the volume is of the new is 1/4 of the original. So that means this, anytime I have that factor, it's saying that I can take 1/4 of any of these and it would be fine, meaning this. Let's actually find our volume of this first. So I have length times width times height, and I have length is 16, our height is, our width is 4, and our height is 12. All right, so it's saying a surface area, our volume of original is going to be equal to 768. And what you can do is, if you wanted to, you can say, all right, I need to take that volume and I need to take it divided by 4, since it's going to be 1/4. So my new volume has to be 192. And what you could do is you could find the volume for each of these, or you could look at the attributes, the length, width, and height, and say, okay, is the length 1/4 of the old length? So I like to do it both ways. So let's say I have, for that first one, so 2 of the attributes have to stay the same, and the other attribute has to be 1/4 of the original. So if I do 1/4 times 16, so let me do, let's put it over here. So I can have the combination of this. I can have a 4 for the length. For width, I can have a 1, and for the height, I can have a 3. And I'm not saying that it has to be 1/4 to each of these. I'm saying it can be one of them, meaning if my length is 4, that means that I have to have the original width and height. If my width is 2, if my width is 1, that means I have to have the original height and length. So make sure you're seeing those carefully. So we're going to say like this. Let's actually just calculate so I don't confuse people anymore. Let's just calculate these volumes. So I can say, let me take this out. All right, so for this volume, it's 384. So this is 384, which is not what we're looking for, so it can't be that. We have a length of 16, a width of 1, and a height of 12, which is good. So this is that case that I was talking about. It has 2 of the original dimensions, and it has 1/4 of the original and 1 of the dimensions. Same thing with the third one. We can have, this is 4 and this is 3. This is also going to be 192. However, for that third one, I said that it cannot be this combination since that is too small. Again, you can also check. It says the height 3, this is 1, and this is 4. Again, that is only 12, which is not what we need. So that volume is 12, which is too little. What about 8, 2, and 6? That's only 96, which is not what we need. Let me cross out there. And what about 4, 4, 12? 4, 4, 12. That actually does work out. All right. Moving on to the next one. It says for number 2, the two rectangular prisms have bases with the same area. The volume of prism B can be found by multiplying the volume of prism A by what factor? So we're going from A to B. So from A to B. All right. So now we can say this. If we actually look at this ratio, we can say, okay, it has to be, since we're talking about volume, it has to be that scale factor. So what we can actually do is we can look at these two values and say, hey, if I'm going from 10 to 2.5, what's going to be that change? Well, I can write it like this. I can say, I can have this, I can say 2.5 over 10 is going to be the same as 1 over 4. Again, you can use those decimal values if you want. You could say 2.5 over 10 is going to be the same as 1 over 4. You could also do, if you wanted to, you can do a percent change. So I can have my big number minus my small number over the original. So I'd say my big number is 10. My small number is 2.5. This is an actual B percent change. So let's not use that one. Let's back up. We're saying that these ratios have to be the same. So we could say, okay, the volume of the first, which is 10, I can multiply it by 1/4 to equal the volume of the second, which is at 2.5. All right. For the next one, for number 3, it says the dimensions of a rectangular prism are shown. The height of the prism is changed from 4 to 12 feet, while the other dimensions remain the same. Again, that key part. What is the volume of the new prism? So if we're going from 4 to 12, what do we have to multiply by? Well, we're multiplying by 3. So we're going to say, okay, the volume of the original picture, we have 4 times 3 times 2. And what we can actually do is we can save some time and we can say, hey, just take my answer times 3. And so he's saying the original volume was 24, but the new volume after that dimension was changed is 72 feet cubed. For number 4, it says a rectangular prism has a volume of 765 cubic inches. The width of this prism is changed from 8.5 to 17. So again, notice that change. We have 8.5 to 17. That means we're a scale factor of 2, so we're multiplying by 2. Other dimensions are changed. What happens to the new prism? So again, it gives you the original, and so what I can do is multiply that. I have 675 times 2. So our new volume is going to be 1,530 cubic inches. So inches to the third power. All right. Moving on. For number 5, it says a planar box is shown below the new box created where the width is going from 12 to 24. So this is times 2. This times 2. And then we have which of the following statements is true about that surface area. Well, if you notice on the front, we talked mainly about volume. So anytime you have that scale factor for volume, it's going to work out. However, surface area, it's not going to necessarily uh, still work out the same way. It has its own values. So we're saying, okay, if let's do our surface area of this, so let's say original surface area. Let's type this out. We have 2 times the length times width plus 2 times the length times height plus 2 times the height times the width. When the, let's say, if we length, width, and height, if we say L is 3, our width is 12, and our height is 10. Our original surface area is 372 inches squared. However, we're talking about the new surface area. So what happens to our value? Well, it's not going to necessarily be multiplied by 2, and I can prove it right here. So our new, we could say our new surface area, well, we're saying we take 12 and we're actually replacing it with 24. So our new is going to be 684. So make sure your inches squared. If you notice, you're saying, hey, before when we talked about volume, we just have to multiply that times the volume. However, that's not true with surface area. It only works for volume. So we would have to say that the difference, so let's actually say, let's say this, let's take 684 minus 372. I'm going to find that difference, and so yes, it is going to be D since it is a difference of 312 square inches. For number 6, it says prism C and prism D have bases of the same area. Choose 2 statements that are true. So we're going to have so we have 6 choices, 4 are going to be false and 2 are going to be true. Make sure you can use those test taking skills for yourself. All right, so we have this. If we notice, these 2 are the same. However, the heights of these we multiply by 2. So we could say this. We could say the volume of prism C is half of the volume of prism D. That would be true since we're talking about volume, that scale factor. If we would go the other way, it would be half of it. Again, prism C is less than prism D. Surface area, we can't say that. Again, scale factor doesn't work like that. The volume of prism D is 10 cubic centimeters larger than volume of that. Can't necessarily say that either since we know that it has to be a scale factor. So let's see. Well, actually, you know what? I'm going to take that back. If we actually look, what do we know? What do we know for this one? Well, if we're looking at surface area and we're looking at that volume, can't necessarily say, one way or the other. So let me leave those blank for right now. But what I can do is this. Let's see. Do I have the values? So let's actually find, it says the area of bases are the same. So that means that these 2, or this, we can say this length are going to be the same. So if we want to, we can say, if this length is 1, this length is also 1. So what we can actually do is we can maybe plug those in. So let's find that out. So I'm still going to actually use that formula. So let's see, surface area, if we say that length is 1, and actually, let's say this is 10. Let's say this is 10. Our length is 10. Our width is also 10. And we're just talking about the surface area of C. So if this is 600, surface area is 600, what about the surface area of the next one? It'd be surface area of that would be 1000. And so we'd actually, hey, that's that 400 of a difference. So let's actually see if I change that length to a different value. Let's just leave it at 1. That surface area is 400 or 460 and 10. 240. So you can see the surface area of prism C is going to be 400 less than the surface area of prism D. And then for number 7, it says this. It says the Atkinson family has been renting a storage space for the last year. This year, they decide to rent a unit that is only half of the volume. So half, again, is half of the volume of the previous unit. Which 3 of the following could be the dimensions of the new storage space? So the original is shown, so this is going to be the original. So let's find the volume of that original. So again, we do length times width times height. We'd say length is equal to 6, our width is equal to 8, and our height is equal to 10. And they're looking for a volume that is half of that. So this is feet cubed. So they're looking, so this is original, and we're going to say new is going to be half of that, so we'd say volume is going to be 240. So now we have to find volumes that would be equal to 240. So let's try these out. So we have 6, 8, and 5. This is 240, so that works out. What about 3, 4, 5? That does not work out. It's only 60. What about 6, 4, 5? That's only 120. Or sorry, 6, 4, 10. This actually does work out. 6, 4, 5. That does not work out. About 4, 4, 6, 8. 192 does not work out. And what about 3, 8, and 10? 240 does work out.